It was like October 2013, and I was just like standing outside on the courtyard of Duran, just like staring into the sky, thinking of a problem. Yeah. And you walked up to me and you said, "What are you doing?"
I remember the first time that Ashton and I met, which was when I was thinking about figuring out what group to join.
October 3rd, 2013 is one of the best days of my life.
I described to you what I was thinking about. I was thinking about like ultra-thin materials, and you're like, oh, well, you should use titanium nitride for that. And then we talked about it, and you described why it was good, and then it went from there.
And I remember thinking he was very together, and I felt really proud that I asked him, how is this different from a multi-junction cell? And I thought that was a really smart question. I didn't even really listen to what he said. I was just like, okay, that was a reasonable question. I was pretty anxious my first year of grad school.
Everything just came together, because before we used to get one part that kind of worked, but then everything else would fail. But October 3rd is the day that literally everything worked, and remains one of the high points of my time here.
I think the most lasting impression that I'll have from our group is the people.
My name is Dionne.
I am an assistant professor of material science and engineering at Stanford.
Damn it. My wife is calling. My name is Andrea Baldi.
My name is Xing Hao.
My name is Brian.
I guess I'm originally from Hopewell Junction, New York, but California stole my heart, so I'm actually from San Jose.
I'm from Madison, Wisconsin.
I'm from Egypt.
I'm from India.
I'm from Bangladesh.
I'm from China.
I'm from Bloomington, Minnesota.
Iran.
I'm from Colorado.
My research group is a team of engineers and physicists, chemists, and material scientists interested in creating new nanomaterials and new metamaterials that can allow us to visualize, probe, and control a variety of systems, especially those relevant to renewable energy and biology.
So I'm interested in plasmonics, as many of the people in this group, and particularly how the plasmonic properties change in very small nanostructures that have dimensions down to the atomic scale.
So my research can be briefly described as using light to sort chiral molecules of different handedness.
My research is basically me sitting at the TEM forever and ever, and then learning a little bit about how energy storage works. We are in the Titan control room.
So it's FEI Titan 80 to 300 kV.
The microscope gives us really good spatial resolution, so we can look at the behavior of individual nanoparticles as they interact with different kinds of gas molecules at different pressures. So it definitely is very frustrating sometimes, but I'm also very lucky to be working with one of the best microscopes in the world, so I guess I can't really complain. I think what Andrea brings is a real idea of what are the important problems to be solving in this field, and how we can take such a simple system and do so many complex and interesting experiments with it.
I have been working on this problem for a couple of years, on and off, on this project, and he came in and learned everything that was needed to know in order to perform the experiment. So
there's also a number of things I don't care about, and luckily those are things that he cares about, and things he doesn't care about, I care about. So then luckily that ends up meshing pretty well, I think.
We have complementary OCDs, so fit together, I think it works very well. Yeah. But also, it's really a pleasure to work with Terry.
I reciprocate that.
It's a lot of fun as well. It's of course frustrating, but we laugh a lot and we check stupid shit often when there is some downtime, and we eat shitty food at Tresida. In a way, it's an experience in itself. It's a painful experience, but it's fun.
In my research, I study materials that change the color of light in interesting ways, and my work is mainly in trying to make them brighter.
I'm into banana theft and the psychological repercussions of that action.
So I'm currently working on phase transition of nanoparticles, which can have potential application in energy storage.
I'm just a curious person trying to understand things, but mainly I'm interested to understand things more from the fundamental perspective.
I'm Hadisa, and I'm a PhD student in electrical engineering department.
And I'm Brian. I'm a PhD student in material science.
So So for the most part, light doesn't care which way it goes. It looks the same both ways, and we're exploring material systems and designs that allow light to have a preference.
The idea of pair-time symmetry is utilizing gain and loss simultaneously to obtain new behaviors in photonic systems.
And I would say that Hirise has an understanding of this concept rivaling anyone else out there in the world. She's a world expert in it. And so it was great having someone who had such a strong fundamental understanding of what was happening and what to expect. It wasn't just playing with variables or just experimenting, it was designed from the beginning.
I really like working with Brian. He is actually a very detailed and precise person, very organized. And then even when we were thinking about the ultimate device to make, he was actually very instrumental because he's very familiar with the FIP and the other material systems and fabrication techniques to see that how we can actually make a real device out of that. The thing about living in Stanford is mainly about just the things that we built here and people that we made relationships with, and we were just kind of leaving those persons behind and we were living in Stanford. So I think that from the time that in the morning I came to the office and the time that I leave the office, most of the times are kind of memorable things for me.
So the interesting part about this group is there are so many varieties, and in the group everybody's research seems to have their individual part, but also seem to be connected with the rest of the people. So this is the group I've seen with the most facets of research I've ever been to.
I am studying new nanostructures that can be used to manipulate light in interesting ways.
I'm working on nanoparticles that will light up and change color when neurons fire.
So essentially we are trying to use light to manipulate and control very small objects like sub-10 nanometer particles. We know from Maxwell's equation that light can exert forces on objects. So if we engineer a beam of light in a certain way, we can control an object, trap it, localize it in space, and move it around.
We want to push it to the limit about a few nanometers so we can trap molecules in cells directly.
Essentially, Yang is like our expert in the atomic force microscopy. It makes things much easier to push things and speed up our experiment, for sure.
Thank you, that's very nice. So you don't know, like we fight a lot before. Hammer is skeptical? No, it's not a good word.
We complement each other, like in the sense, like I like to question things a lot more. Yang is more into compiling the data and analyzing them. Now we sync together better, so I think it has been getting better.
Especially after your defense.
Yes. I think we learn more about the nature of science in the sense that you ask a question and then you try to answer the question. Maybe you reach to the answer, but the answer of that question opens a lot of other questions as well that you need to answer. So that was a part of like the excitement of that experiment and sometimes of the frustration of the experiment and of the science in general. But this is the beauty of it.
I'm really proud of the work that all of the students and postdocs in our group have accomplished, but what really stands out to me is just the interactive, collegial, collaborative, and fun personality that all of the students had. And there are certainly aspects of each student and each postdoc that I could comment on. It'd probably take the whole afternoon, but I'll definitely remember the people.
When I'm not in lab, I am often at the gym or in the bathroom, or playing video games, or playing or watching soccer. I think those are my main hobbies.
After too much reading in the office, I'd like to go hiking.
We have a lot of freedom to work on projects like this one, like making videos about our research rather than just doing our research. And we have a lot of good traditions, like having champagne toasts for every paper we publish, where everyone signs the bottle. And Jen has created a lot of little traditions like stand-up and breakfast at group meetings, so there's a lot of cohesion that comes from those.
I think what's unique about our lab is that everyone is extremely supportive, and I think having that really supportive environment just makes research and the frustrations of research so much better.
Actually, Michael was the one that taught me to synthesize my first batch of nanoparticles, so we use kind of hydrothermal pot synthesis. It's kind of like, I guess, baking or cooking, where you mix a lot of ingredients together and kind of just wait for it, and then when we put it in front of the laser to see if it upconverts, that's when you know if you have a good batch or a bad batch. So this is Michael Wisser, and he likes to fart a lot in the optics lab.
This is Alice Lay.
Yeah.
She's the strongest woman I know.
So Michael and I are both working on something called upconversion, which converts low energy light into higher energy light. I was rushing to get results for MRS, and so when we actually started the different pressure measurements, it was already like, I don't know, like 10 p.m. And Mike was really nice. He stayed with me to do a couple of them, and then he had to go home and do his ab workout. And he also went to Safeway to get me snacks, and he brought them over, and then it made the night much better because I ended up staying the whole night, and that was also my first all-nighter, so it was like a proud moment, and also like, wow, what did I just do to myself? Yeah.
I guess outside of lab, my main interest is sports. So I'm a big soccer fan, and I spend a lot of time watching Arsenal as my favorite team play, and I also enjoy playing myself, playing other sports, and just generally being active. But I guess really what I'm passionate about is the energy crisis and seeing what I can do as a scientist to help that problem. And I think that's really what drives me to be the best that I can be.
Something that I love a lot is music. I'm a trained classical singer, and I spend a lot of time practicing and listening. I also love astronomy, and I go to like stargazing, etc. So that also makes me very happy.
The things that I think kind of specific about our group is the social culture and kind of the activity is kind of very unique feature of our lab, kind of very friendly and warm environment that it has.
Yeah, okay, so my favorite things to do, basically, besides be a scientist or even over being a scientist, are playing outside. That's a huge thing. I love rock climbing, I love skiing, I love mountain biking, I love basically anything where I can frolic in the high mountains. So that's up there for me. Also, I like sitting and talking with friends about how we can change the world for the better, and thinking about how I can actually apply myself to that problem in the future. Well, a lot of our work takes place in the clean room. It starts with growing stuff. So we're trying to develop new optical materials. And so to do that, we need to go into the clean room and grow these materials and then characterize their optical properties, see if they're worth anything. My name is Justin Briggs. I'm a waste reduction engineer.
My name is Guru Raj Naik.
Guru Rajmataj. Guru Raj. Guru Vladimir Naik. We have little competitions constantly about who can guess the results of our experiments, or who can do a process better.
Justin is very organized in everything that he does. If we have to go to clean room, say at 2 o'clock, then we start at 1:30 because Justin takes at least 15 minutes to get all this tradition done and ready. So.
The other way to put it is that Guru can just do whatever he wants and it works because he's a boss, but I have to do things slowly and methodically or else they just get all messed up. Guru is like an old veteran. I mean, he's been doing this for a long time and he's legit professor status, so he's got all of the hardcore knowledge and experience, and I sort of am a beginner in a lot of these things, so I have the beginner's eyes, and the combination of the beginner's perspective plus the extreme wisdom create the potential for good ideas, I think.
The first thing that comes to my mind when you say Justin is probably, oh, sweet. And if you ask him, what all do you eat? So he would say anything that is vegetarian, salmon, and honey that comes from the mouth of bees. So that's exactly what he would say.
What? Are you referring to the one time that I said honey is bee vomit?
That comes directly from the mouth of bees.
I have no idea what you're talking about.
That's what you said. I couldn't forget that.
I guess politics is one of the things that I'm really passionate about. I'm also really passionate about some science that is not my science. So I really enjoy biology and evolutionary biology and neurobiology, and I guess it's intertwining with morality and free will and philosophy.
Yeah, so I'm an active member of Students for Alternatives to Militarism, so the anti-war effort on campus.
Yeah, outside of science, I'm really interested in music. I perform saxophone and piano in a number of groups. So yeah, I've done everything from like funk bands to klezmer to jazz groups.
I think we see each other a lot more as friends than coworkers, and we have much more discussions that are not science related, and many more shared interests outside of science than I think the average lab does.
I'm really passionate about public radio and public media. I love listening to podcasts and making them. I also love going swimming with my pal Ashwin in the D Lab, and just enjoying living in the Bay Area. Stanford is in the middle of an incredible place to live and play and eat and work. So when we did start doing experiments together, it was really fun. There was like a month, I feel like, where every morning I would wake up and like Ashton and I would like do science together, and then we'd go swimming together, and then we'd set up some shots for our video together. And then we like talk about it, and it was just like a day where we were like basically this close to each other the whole day and doing all kinds of different things. So it was really fun.
Woo dog.
I want you to introduce me again.
So this is the wonderful Dionne Wu.
This is Ashwin, my partner in crime in making this video, as well as swimming and upconversion and just generally hanging out.
Making these videos has been a challenge, but like a totally different type of challenge, and very fun, and like pushed our creative sides in ways that I definitely didn't expect to get to do at work, more or less, which has been a lot of fun. That speaks a lot to like how cool Jen is, honestly, like as an advisor, just being okay with letting her students like pursue sort of alternative interests and really not focus on science temporarily. We're lucky to
super lucky. The one challenge we definitely haven't faced is like feeling like we don't have the freedom to pursue activities like this together. And like this is something that would be super hard to sneak around and do, and like not only does Jen let us do it, she like encourages us.
And she participates too.
Yeah, that is really special and has made grad school awesome.
I guess my personal experience with Jen is like a happy experience, because she's the reason why I spent the last 4.5 years in this amazing place. So she's always, a happy thought.
Jen's favorite quote she always tells us is this thing that Conan O'Brien said, which is, work hard, be kind, and amazing things will happen. And I feel like she embodies that very much. Stanford.
I don't know, it was a dream.